In this session, we are going to discuss a new topic in ArrayList. Earlier, we looked at linked list and we also looked at an array data structure. Starting today, we will shift our focus to a new data structure in an array list. But this should be pretty familiar to us because when we had developed the shopping cart example in one of our earlier labs, we had looked at how an array can grow in its size. So that's exactly the same thing that is being done in an array list. So an array list is a dynamic array that internally uses an array data structure. The initial size of such a data structure is going to be 10, and then the array would grow using the formula that's outlined here, where n is the current capacity of that array. So you can see that it is n plus n over 2 plus 1. Initially the array size is 10. So the next time it would be 10 plus 10 over 2 plus 1, which is 16. And the next time it would be 16 plus 16 over 2 plus 1, which is going to be 25. And then it will grow as it is. Every time you reach the end of that array, while we are adding new elements, then the array would grow in its size. So it's worth to note that we had done similar example in our shopping cart lab, where we had the array grow in its size basically by adding 5 to its capacity every single time. So when we compare this with a linked list on the other way is going to be a complete dynamic data structure where there was no size requirement, right? And the list simply would grow as new nodes are inserted. It was good for insert and delete operations, whereas an array list is good for get operations. And we will do some experiments in this session to validate all these that we are talking about. First thing first is I like to go over a simple example of an array list where we could perform operations such as add, remove, update, and get. So I'm going to open up this ArrayList.java. The class name is called ARL, which is the array list. And this would also be available for us here in our repository for today. And you can see the first important step when we are using an array list is we got to have the import statement. And the import statement for an array list is import java.util.arraylist. And ArrayList is simply an external library that's available for us through the Java framework. And the next step for us, if we'd like to use an array list, is simply we create array list of the particular variable here, student ID, and then it's of type array list. And then we can use an add method in order to add any values to that array list. So here we could see that I had added 10 different student IDs, and then I'm going to print that student ID. So you could see that we could simply use the variable here, student underscore ID, and we should be able to print that student ID, all the student ID in the array. And if we want to delete an element, then we simply use the dot remove method and we pass in the index. So in this case, I'm saying that, hey, can you remove the second element and the fourth element in line number 16 and 17? And then we are trying to print that in line 18. And you could also see that in line number 19, there's two type of remove functions that are available. One is remove by index, and the other one is remove by value. So let me go back, and here I'm going to make a note that there is remove by index and remove by value. So there is two such remove methods that are available, as you can see right here, right? And then you can also see that in our code we are trying to remove, in line number 19, we are trying to remove the value that is currently 10007, which is the student ID. So we simply need to use the integer here, and then we can use the remove, right? So a remove is done, and then in line 20 we simply print all the student IDs that is available after we do the 3 remove statements. And then you can also see in line number 21 to 23, we are doing an update. An update is done using set method, right? And it takes in 2 arguments. First argument is the index number that we like to update. Second argument is the value or the new value that is going to be updated. So here we are saying that, hey, can you update the element in position 4 with a value 20008, and then 5 and 6 and so on. And then later we simply print that new modified array list in line number 24. And I like to go back to the terminal, and I'm going to compile and run this program. So you can see that at this point, initially we had 10 elements in that array, and then later we removed certain elements. We basically removed the third element, and then we removed the sixth element. So basically, by using the index number, if we can go back, you could see that we removed 2, which is the index number 2, and then index number 4. So you can, I'm going to count here 0, 0, 1, 2, right? So 2 was removed initially, and then I'm going to count again 0, 1, 2, 3, and then you can clearly see that 4 was that 6, right? So 6 would be removed. And keep in mind, every time we do a remove, the value would be removed, and thereby the index number would be changing, right? And then you can see finally, after we perform the update, we get the modified array list displayed here. But then how does a remove work? How does the we talked about how the array list deal with the add. Basically, as we grow the array in that shopping cart, initially they would have 10 elements, and then later 15 elements. Later they change it to 16, and then 25, so on and so forth, right? So they're going to grow the array as new elements are added. But how does remove? How does the remove happen? So let's try to understand the process that's followed by array list for a remove. So let's say that you have 10 elements, right? And let's say if I want to remove the first element. So all the array list do at that point is it's going to shift all the elements to the right of the element that is being deleted. It's going to shift it left. So here you could see it shifts all the elements to the left, right? So you can simply go ahead and shift all the elements here to the left. And then let us say that I want to delete again 4, right? Let's say I want to delete the 4th element. Then what we do is we are going to shift all the elements to the right of the element that is being deleted. We are going to shift it left. So now you can see that 4 is being deleted. Let's say if we want to delete 7. then we simply going to have all the elements to the left of 7, and then all the elements to the right of 7 is going to be shifted by one position to the left, right? So you can see clearly the remove process works based on a lot of shifting, right? So clearly, compared to a linked list, this is going to take a long time because there is a lot of shifting that needs to be done. Let us say, hypothetically, if there are a million items in the linked list, and if we are trying to delete the first item, so one less than million items should be shifted to the left. And that's a lot of work to be done, right? So clearly a linked list would be a winner when it comes to the delete operation, because it takes just matter of removing a chain and then adding a new chain. So you probably might remember how we performed a remove in linked list. So it's just a matter of the chains, right? So we just need to take care of the chains, and then we are done with the delete operation. So there is no shifting that we did when we did a linked list delete. So we will shift our focus here to do some experiments. Now that we talked about how an array list works, and then we compare that with a linked list and an array, let us look at this link stub.java. So this code is just a slight modification to the linked list code that we had developed in our earlier lessons. So we are still using the linked list code, but we are doing some modification in the link stub.java, as you could see right here. So in the main method, you can see that initially the size of the list is declared here. So we are setting the size to be 100,000, and then later we are performing a linked list add, and then we will do an array list add, and we will do a regular array add, and we will perform a dynamic array add, right? So a dynamic array is simply the extension of what we did in our previous lab for the shopping cart. If you recall, we simply grow the array by creating a temporary array. So that's exactly what is done inside an array list. We are trying to do what an array list is doing with its add, except that we are writing our own array list add. And then you can see that we would call the get method for linked list, and then we will call the array list get method, then we will call the regular array get method, and then dynamic array get method, and then later we will call the remove methods for each of those as well, right? For the linked list and array list. So let's go over the code here. A linked list add, this should be familiar to all of you. I'm not going to go over the concept of linked list again. Simply we create a links object, and then we are doing a link.add, like what we did in our previous lessons, right? One thing that you might note here is we are trying to do some experiments, and we are using a system.nanotime, which will give us the nanoseconds. So if we want to measure the execution of a program programmatically, and if we want to measure that using a timer, then we simply do a start time and end time, and then we can do a total time, which would be end time minus start time. And you can see that this start time is of type long, which is simply an extension of int or double, except that it can hold a lot more range of data, right? And then finally we will print that total time. So please keep in mind, we are now also learning how to run experiments in while dealing with a data structure, right? So the way we run experiments in Java is we would use a system.nanotime to measure the execution of a program. And here you can see for a linked list remove, we'll simply accept the link, and then it was going to remove the first element in that link. For all the throughout the linked list, we run the for loop, and we are trying to remove the first element every time, and we are measuring that as well, right? And the get method is simply trying to get each of those elements from the linked list, and it is adding that to a dummy variable called sum, which we are not using anywhere, but we are simply testing the execution time for our linked list get. So the sum here is not used in the program directly, but it's still going to simulate the execution of the linked list get. And ArrayList get, we looked at how to do ArrayList add earlier. So it's exactly the same process. We create an object of that ArrayList, and then we do a dot add, and we are doing that over here to measure the ArrayList add time. And ArrayList remove is we are calling the dot remove of 0 in line number 48. Again, we are measuring the remove time. And if you look at the ArrayList get, we exactly follow the same thing, except that instead of a linked list, we are using an ArrayList.get, right? And then we are adding that to the sum as a dummy variable, and we measure the ArrayList total get time. So if you look at the method in line number 66, this is where we are using a regular static array. So you could see in line number 68, we create that array with 100,000 elements in it, right? So that's really an expensive operation when it comes to the notion of insert, because we need to insert them one at a time all the way through, right? And that's for 1 million elements. Okay, so then we are simply trying to print that. And this line number 66, we should all be familiar with that, because we have done such a static array creation a lot in our earlier lessons. And line number 77 is a modified version of the static array. We call that a dynamic array. And really what we are trying to do here in 77 is we are trying to implement what the ArrayList.add is doing internally, right? So here you can see that initially the capacity was 10 in line number 79. We create that array with capacity 10. Then we run a for loop. We check if it is less than capacity, we add the element to the array. Else, we are going to make the growth in the array, right? So we are going to grow the array by doing a capacity equal to capacity plus capacity over 2 plus 1. We are updating the new capacity, and then later we are creating a temporary array in line number 89, and then we are going to do the array equal to temp and add that element in 95, right? So here really what we are doing is we are creating a dynamic array similar to what is being done in an ArrayList.add. And we are doing these so as to make sure we can compare the performance of each of those data structure. And then you can see that array get is simply in line number 108, we get the individual elements using the square bracket, right? And we add it to the sum. And dynamic array.get is again doing similar thing, where in line number 118 we are doing an array square bracket I equal to the sum. We are adding that every single time, and we are measuring the get time. Okay, so now that we looked at all these individual methods, let us go back to the terminal, and I like to run the program so we can do some experiments today and understand the performance gain from each of those different data structure. So let's do a link stub. And here you could see that we had already created the linked list, the array list, the regular array, and the dynamic array. And the size was 100,000. And then later we are doing a get, and the time is given right here on the right hand side. And then finally we are removing all the items, and the size of that linked list and array list becomes 0. So let me copy this information. I like to go back to my text editor, and I can paste it right here. We will go over the experimental results. I'm going to format it a little bit for us to see it clearly. All right, so you can see that clearly from all these results, the regular array for add was pretty less in time taken, right? So I'm going to put that all the way in the top, and this is a static array, right? A static array, as you could see clearly, adding a new item to that static array was less time taken because they are all consecutively located. You're simply going to add new elements every single time. But keep in mind, here we fixed the array size as 1 million or 100,000, right? So it is fixed in its size. It's no dynamic, right? So then we are wasting a lot of space if we are doing this approach. But then what we are really interested in is comparing the linked list with the array list and the dynamic array, right? So you could see the linked list total add time was 344,2571 nanosecond. And then you can see the dynamic array was 360,691 nanosecond. And the array list took a long time, right? So a dynamic array that we did was similar to an array list, but still it's our own implementation of an array list. So this is why it was taking lesser duration compared to an array list, right? And then you can also see that both these approach are lesser than a linked list add time, right? So linked list is clearly much better when it comes to the performance of add compared to an array list and a dynamic array. So now we will go and look at the get performance here. So again, I'm going to pull in the least execution time, which is the static array, and that's the best one, right? So static array is the best one. And then you can see, let me format this data a little bit. So then comes the dynamic array, and again, dynamic array for get is pretty performance wise is going to be better here, and I should say it's better than the dynamic array. So in this case, although that they are pretty close in terms of nanoseconds, so they're trying to do kind of the similar thing. I wouldn't say that one is better than the other, because they are doing the same thing when it comes to the get. So the numbers are off just by a little bit, which is fine. And keep in mind, here's all the numbers are in nanoseconds. So nanoseconds would be 10 to the power minus 9 of the second, right? So really it's much lesser than a seconds. And then the array list get time was 39888799. But look at linked list get time. Oh, I think that's the most expensive one, right? So when it comes to get in a linked list, we need to follow the chain a lot, and thereby this is going to be more expensive, right, in terms of our experimental result. So let's also do the comparison for a remove. You can see that a linked list remove that is given here, which is for the delete, takes much lesser time than an array list remove, right? Array list delete That will take a long time because, as we had learned earlier in this session, that a remove in our array list has a lot of shifting to be done, right? Whereas a linked list remove is just a matter of changing the chain, and then you can see the performance advantage here clearly is that linked list is much faster for a remove than an array list, right? So with that understanding, I'm going to go back to this notes. So we could see that an array list is good for get operation, whereas a linked list is clearly good for insert and delete operations, right? Um, so that's the comparison for today. And we had to recap our discussion. We looked at what is a new data structure called an array list, and we compared that with a linked list and an array. And then we also learned how to do experimental results, and then how to perform experiments in a Java program so that we can clearly see the performance advantage. So the class activity for today is I like you to increase the scale of this program. Currently it is 100,000. I like you to increase the scale to multiple levels here. So let's say that we want to increase this scale and measure the performance for 100,000, then 200,000, all the way up to 500,000, right? And please also try, you may run into an error based on the capacity of your machine, but I like you to also try some experiments till 1 million, right? And then please make sure that you create a table like what we present here. Please create a table of that experimental results for each of those, add, get, and remove, and post your solution in our GitHub. You can create such a table using a markdown file, or maybe you can use a Google Doc to create a table. And then I like to see all your experimental results. And it would be a fun process for you as well, is that clearly you're learning how to perform experiments, and also we are learning a new data structure in an array list. And again, I like to repeat myself. Array list is no different than a regular array, right? It's still an array that we had seen earlier. Internally, it uses an array, except that it will grow dynamically, meaning it will increase its size every single time. But a linked list is clearly a huge performance advantage when it comes to functionalities such as insert and remove, right? And then we are using a list of chains in order to achieve such performance advantage. Okay, with that, I'm going to end this video here, and thanks for listening to this video.